Let's work through some worded problems about cost and inventory, as we've been working on before with addition and multiplication, using matrices to represent large amount of data or numbers, information. We can then perform operations, so operations is addition, subtraction, multiplying, all in one go rather than doing them one at a time. So having a look here at some ice cream sales, let's imagine these numbers here. The 10 is the number of Magnum sold, Cornettos, and then Gaytime sold. So we've got, what would be the order of this matrix here? How many rows? 1. How many columns? 3. So we call that a 1 by 3. Now what about the profit for these? Imagining these in dollars, $1.10, $1.80. What's the order of that matrix? How many rows? 3 by 1. And so this is the profit per Magnum in the first position, then the Cornettos, and then the Gaytime. So you can sort of see how the elements correspond, like the first position in each of those. So what if we wanted to find the overall profit? What we would need to do if we didn't have matrices is multiply the number of items sold by the profit per item and do that 3 times. So the number of Magnums sold multiplied by the profit per Magnum, there's a multiplication, then add on the next ice cream amount by the profit, and then add on the third one in the profit. So as you can see, it could get quite tedious. So to do this with matrices, we can essentially take the matrix, that is the number of sales, multiply it by the matrix which represents the profit. Doing that one calculation, that will give us the overall profit. If we represent them by S here for sales and P here for the profit, multiplying those together. But which way around should it happen? Do we do profit times by the sales or sales times by the profit? Because if we were doing it by hand without matrices, it wouldn't really matter. So does it matter with matrices or not? We need to think about their orders, but also the meaning of the results that we get. Let's just have a think about the orders, because in that previous video where we've talked about matrix multiplication, can you even do it if the orders are compatible? So let's look at S. What's its order? How many rows? It's a 1 by 3. And P, how many rows? That's a 3 by 1. So P multiplied by S would give us which orders? The 3 by 1 multiplied by S, a 1 by 3. Can you do that? Yes, because those ones in the middle match, the resulting matrix would be the 3 by 3. So we could do that multiplication. What about S times by P? Putting the order there for S, multiplying that by P, a 3 by 1. Those middle numbers match, the 3's, so the resulting matrix would be a 1 by 1. So which one is it? Sometimes in matrix multiplication, you won't get those two options, so you won't even have to think about it. If we do P multiplied by S to get this 3 by 3 matrix that we predicted would happen, here are our numbers. Well, what do they even mean? Let's have a think about the numbers in this second row here, this 10, 15, and 9. This 10. Let's have a look at the titles at the top of the columns and the rows here. So rows M, C, and G, Magnum, Cornetto, Gaytime, Magnum, Cornetto, Gaytime. So it was the P, the profit, it was the first matrix, multiplied by the sales. So this one here is the profit if a Magnum is sold at a Cornetto price. Essentially, it's a bit like map reading where you read the rows and the columns. So notice that this is an M here and a C there. So this is the profit of the Magnum, because the profit came first. So this up here represents the profit. And here is the number of sales. So the profit of a Magnum multiplied by a Cornetto price. That doesn't really even make sense, does it? What about this 15? Well, these C's do line up. So that is the profit if a Cornetto is sold at a Cornetto price. Okay, that makes sense. But what about the G and the C then? This is the Gaytimes sold at a Cornetto price. That doesn't even make sense. So as we've said there, most of that is useless. It's actually only the diagonals that help. It's the Magnums sold at a Magnum price, Cornettos at a Cornetto price, the Gaytimes at a Gaytime price, and then adding those 3 up to get this profit here. But if you didn't know just to look at that diagonal matrix, you might be very confused with all that extra information, and you might add them all up and claim that is the profit. So obviously, then we're going to do it the other way around. We're doing the 1 by 3 by 3 by 1, and then we'll get that 1 by 1, because that's like our final single answer that we want. So this is how we do that. We've got the 1 by 3 and then the 3 by 1. Either doing them by hand where you multiply each of these, so you go across the row, down the column, and then add, and that gives us $33.20 as our profit. That's something that you need to take into consideration. If the question is asking you for a total profit, that means you need to end up with a 1 by 1 matrix. So think about which way around that you do those multiplications, so that is your answer. And the way to get that is making sure these middle numbers match and the outer numbers are the ones. So thinking about which way you place the pairs of matrices. As a side note now, some of these questions in the book are not all going to be exactly like the example I've just done there. I've gone and had a look at them. Often the questions will tell you, now construct a row matrix, which is a single row, and it might ask you to put the cost in, or it might say now construct a column matrix. And so often follow the instructions there. I did also notice that sometimes you're given the option of where to put the cost. You could put it what's called on the left or on the right. So what is the order of this matrix here? How many rows? It's a 3 by 2. If you were to construct a matrix to the left of that, so over here, what does its second number need to be? It needs to be a 3. And the first number quite often is a 1 if we've got a sort of a single cost for each of the items. For example, you might have store A and B, and they're selling the different magnums or the different ice creams, and therefore the cost amount that would go here is a 1 by 3. Or you can post multiply it, which is then over to the right hand side, you would have a 2 by 1 perhaps, which would mean 2 rows and 1 column, and doing some multiplies there. But as you can see, there's 3 elements here and 2 elements here. That's why you need the context of each question to decide which one will be the most appropriate. The other thing I do want to mention is if you ever get a matrix that's square, so that's a 2 by 2 or a 3 by 3, if you ever see that with something up here, a little power, you can do that in your run menu. So you would bring up matrix A, and then you would either use what's called the little hat button to raise that to the power of 3. And let's say you called that matrix C, therefore on your run screen, if you type mat C and then you do the little hat button to the power of 3, well, it will create a little box up there for you to put a 3 in, and then enter, it will give you the answer. So just a little tip of what to find there. And by the hat button, yes, it looks like a little arrow and it's next to the exit. I hope that helps. Thanks for joining me.